find the gradients of the tangent and the normal to the curve y equal to x squared plus 2x plus 2 at the point 2, 10. So in this question, what they want us to find is the gradients. They want us to find the gradients. So when you're dealing with normal and tangents, what is required first is to differentiate this curve. You have to differentiate this curve so that it helps you to come up with the derivative. The derivative which will lead you to the gradient. So I'm going to write the curve, which is y equal to x squared plus 2x plus 2. Now there are several methods you can use when you're differentiating. You can use product rule, chain rule, quotient rule, first principle, power rule method. Now the only method that is easy to apply is power rule method, which states that y dx equal to a n x then n minus 1, which simply means when you have the curve given like so, you have to multiply the power to the coefficient of x, then you reduce the power by 1. So this one will be dy over dx, which is equal to 2 times x, which is 2x, then 2 minus 1. Then coefficient of x here it's 2, and the power it's 1, though it is invisible. So 1 times 2, it will be 2x, then 1 minus 1. This one has x to the power 0, which is invisible also, because any number is to power 0 except 0 itself is 1. So we have to show that variable. So 0 times 2 to be 0. Or in other words, whenever you're differentiating a constant, you have to make sure that you have a derivative which is 0. It should give you 0 always. So dy over dx will be 2x, then 2 minus 1, which is 1, plus 2x, 1 minus 1, which is equal to 0. Then you ignore the 0 that side, which is a constant. So it will be dy over dx equal to 2x plus 2, open bracket, x to the power 0, we said it's 1. So we have to replace where there is x to the power 0 with 1. So it will be dy over dx equal to 2x plus 2. So this is the derivative. So now you have to use the derivative together with the coordinates given. Now this time you should use the x coordinate, which is the x equal to 2, the x coordinate, and you pick the derivative. So dy over dx equal to 2x plus 2. So in this derivative, where there is x, you have to replace 2, so that it becomes dy over dx equal to 2, open bracket, 2, close bracket, plus 2. So dy over dx equal to 2 times 2, it's 4 plus 2. dy over dx equal to 6. So this is the gradient. This is the gradient. Now the gradient here, we haven't specified whether it's the gradient for the tangent or for the normal. What you should know is that the first gradient that comes out from this curve is regarded as the gradient of the tangent. Therefore, mt is equal to dy over dx. So mt is equal to 6. So this is the gradient of the tangent. So now to find the gradient of the normal, mn, we are going to borrow the concept of coordinate geometry. When two lines are perpendicular to each other, their product of gradients is equal to -1. So when we have m1 and m2, if we multiply the two, their product should give us -1. So what I mean is m1 times m2 should be equal to -1 from the coordinate geometry knowledge. So now we are going to convert this equation to mt times m normal, which is equal to -1, where mt equal to 6. So where there is mt, you have to replace 6 times m normal, which is equal to -1. So now both sides, you have to divide both sides with 6, so that your m normal is going to be -1 over 6. So this is now the gradient of the normal. So if you multiply 6 to -1 over 6, the product should be -1. So this is how you should go about when you are asked to find the gradient of the normal and the gradient of the tangent. If there are questions, you are free to ask. Thank you.